All right, so let's try to finally finish up this lesson. All right, so I said, as you guys were walking out yesterday, I yelled out, I didn't really yell it out, but I said what we're going to be studying today, and I said, have you ever seen this? And my guess is you probably have not. I don't think I've ever seen this taught in Algebra 1. It's definitely something in Algebra 2. It's called this. It's called the greatest integer function.
How does that compare to the greatest function?
It's not even close to the same. All right, so the greatest integer function. The greatest integer, that's the key part of this. All right, it's the largest integer. And we have a little notation for this. So when it asks for a greatest integer function, it looks like this. It's a little bracket, and just put an X in there. That means it's the, what this means is, right here, it means it's the greatest integer. Let's write it down. At first, when I first write this down, you're going to say, okay, I still have no idea what that means. But after we do it and show you the graph and that kind of thing, then we'll look back at this and it might make a little more sense. It might, okay? So it's the greatest or largest, right? Oops, if I could spell right. It's the greatest integer, the largest integer, less than, whoops, I forgot the less. There we go. Less than the value of x, or just x. All right? So, for instance, if I gave you a number like 2.7, all right? Everybody watch. So if x is equal to 2.7, and I said, find this. What does that mean? It means find the largest integer that's less than x. So if I'm finding, actually I shouldn't have put it, I don't know why I put an x in there. What'd you say? It's 2. Why? Because that's right. Integers don't have decimals or anything, okay? So what's the biggest integer that is, what's the largest integer that's less than 2.7? 2. All right, actually, I meant to put 2.7. And then what is it? It's 2. You with me on that? All right, let's do another one. What if I said 3.1? What's the greatest integer less than 3.1? It's just 3. Okay? What if I said the greatest integer function of 4? Trying to think of an explanation here. The greatest integer. Yeah, according to this, it would be 3, right?
Why can't it just be 4?
But it is 4. Yeah, good question. That's what I'm trying to. That's why I'm stalling, because you would ask me, wouldn't you? But I'm trying to figure out why. According to this, that doesn't make sense. There must be a little bit more to this. So I probably have to look at the actual definition. But let's just say this. I can't give you a good explanation according to this, but the greatest integer function of 4 is 4. Okay? So that's what they do. All right?
Why is that?
Okay? Everybody with me on that? Again, my explanation stinks on this, but that's what we're talking about. So, again, if I looked in the book, I try to simplify the explanations they give in the book, right? Because sometimes it just makes no sense. And I probably simplified it a little too much. There might be a little bit more to this about, like, if it's an actual integer, just use that integer or something like that. So if you look in the book, it may explain that better than what I did right there. All right, let's do some negatives though. Okay, so because the negatives get a little bit tricky. What if I said negative like 2.7? So yeah, so sometimes it helps doing this. So negative 2.7 would be between what? Negative 3 and what? Negative 2. Would you agree? So it's probably somewhere right there. So what's the largest integer that's less than this value right here?
3.
It's got to be less than. Negative 2 is greater than, right? So what's the integer just to the left of that? It's negative 3. Okay? Does that make sense? So that sometimes can be a little confusing, right? Because if it was positive 2.7, what would you say? You'd say 2, All right? You follow me on that? So it's the integer that's just to the left of whatever number I'm telling you. Yes.
For the greatest,
This one right here?
The greatest integer less than or equal to.
Oh, it says less than or equal to. Good. Okay, good. So I knew I missed something. Less than or equal to. Thank you for that. I thought there was a little bit more to that. Thanks. So less than or equal to x. So that makes sense now. Okay, so the greatest integer function of 4 is 4. Does that make sense on what the greatest integer is?
Yes.
All right, so now what we're going to do is we're going to graph it. All right, so this is where it gets a little confusing. Let me grab a graph here. And we're going to graph y equals the greatest integer of x, right, in the brackets. That's what we're going to graph. Let me put this graph up first. We'll make it pretty big because, there we go. So what we're going to do is we're going to graph y equals the greatest integer function of x, okay? If it helps, at first, I think it does help. Let's do this. So let's put some values in for x. Okay, not a whole lot, but let's put like, I don't know, -2. I'm going to leave a gap here. I'll show you why in a second. -1, 0, 1, and we'll put a 2 way down here, all right? Because I'm going to fill in not every one of these. Once you get the pattern to this, then it's really easy to see, all right? But we just want to figure out what that pattern is. So let's just do the integers themselves. So if it's less than or equal to, the greatest integer, right, less than or equal to -2. So what's the largest integer that's less than or equal to -2? -2. And so what's this going to be? -1, 0, 1, 2. But what about the ones in between? And I'm not going to fill in every single one of these. Once you get that pattern, you kind of get the idea. So watch. Let's do like -1.25. And let's do -1.5. I would do -1.75. I just ran out of room. Okay, but you get that's enough to get a pattern going here. All right. So if you had -1.25 again, like this, where is -1.25? It's between what? It would be right there, wouldn't it? Okay. So what's the largest integer that's to the left? Okay, or less than -1.25. What would it be? It'd be -2, wouldn't it? All right. So this would be -2. So that goes with that. What about 1.5? -1.5. What's the greatest integer of that? It's still what? -2. Everybody with me that? What about, how can I explain this? Yeah, and then look, we get smaller and smaller and smaller. It's still -2. What if that was like -1.1? It would still be what? 2. What if it was -1.0001? It'd still be -2, but then it would just completely jump to what? To your next integer, which is -1. You with me on that? All right, so let's do it. Let's do a couple more just to kind of get this going here. What are we going to do here? Negative what? Let's go right in the middle. 0.5. This would be what? -0.25, and this would be negative what? 0.75. Yes. All right. So what do we do here? What's the greatest integer function of negative? Again, -0.75 would be right here. So what integer is just to the left of -0.75? -1, -1, -1. Do you see that? Until you jump to the next one. You with me? Then all the numbers in between here are going to be what? 0, 0, 0. Now there's a lot more numbers than just 0.25, 0.5, and 0.75. Agreed? So what are we going to do with all those numbers in between there? We're going to shade them all in, right? We're going to make a graph out of it. Okay? And then what about this? All the numbers in between 1 and 2 on the x-axis, what's that going to be? It's going to be a 1. It's going to be a 1. It's going to be a 1, and so on. Okay? So let's come over here and let's look at the graph. So you could put -2, -2, correct? Right there. -1, -1, 0, 0, 1, 1. So for each integer, you could just go to where it is on the graph. That's right. But you're going to do some more, though. Because let's do the negative 2. Between negative 2 and negative 1 on the x-axis, do you see right here? Between here and here, what are you going to do? Let's make this a little bit bigger because it's kind of small. Look at this. These numbers right here, if I go to negative 1.5, where do I go on the y? If I go negative 1/2, what's the greatest integer function? Or what's the greatest integer of negative 1? It's negative 2, isn't it? So I could put a dot here, dot here. I could put a whole bunch of dots, right? Until I get where? Until I get to negative 1, and then what's it do? Just jumps up, doesn't it? So what am I going to put right here then? I got to get as close as I possibly can to that point. So I'm going to put an open circle. You see that? So if I go negative 1.1, that would be right here, right? Negative 1.01, it'd be closer and closer. Negative 1.001 is closer and closer until I get to what? Negative, so right, it gets super, super close, but as soon as I reach negative 1, what's it do? It jumps up to here, okay? That's why it's open here, right? It can get super, super close to it until it actually hits the integer. Once it hits the integer, then boom, it pops up top here. Okay? What about the numbers in between 0 and negative 1? Right? Like negative 1/2. What's that going to be? It's going to be negative 1, right? Negative 0.25 is negative 1, and so on. So what are we going to do here? Going to shade it in until we get to the next integer. Then what do? Open, and it pops up. That should be closed right there. Pops up to here. Now, you kind of see how the pattern is, don't you? All right, so let's keep doing it. Go to here and then open, pop up to the next one, go to the next integer, it's open, pop up to the next one, and it's open. You get the idea. And that's what a greatest integer function looks like. They call it a step function, because it looks right. Boom, 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 boom. Looks like steps, doesn't it?
Yeah.
All right, so they call that a step function a lot of times. All right, but that's your greatest integer function. That's how you graph it. What do you think?
Looks pretty annoying.
But once you get the idea, it's not too bad, is it? Yeah, it's not hard. Okay, but that's what it means. And hopefully, I think I gave you a pretty decent explanation of it, to tell you the truth. Better than I have in the past when I first started teaching this stuff. Yeah.
What is like the point of this graph? Like, what would you use it for?
You know, it's a great question. You're asking me very good questions that I don't have answers to. But if you do look in the book at the very beginning, well, I don't know if it's at the very beginning. I think it's right before they talk about the greatest integer. I think they give you some like scenario where you could use it. It can be used. Do I use it in my regular life? No, only when I teach it. That's the only time I've ever used this thing. But I have seen things where you do use that graph. In what is it? Statistics? And what? Engineers?
You said
Engineerics. What word's that? All right. Anyway, there are uses for it. I can't tell you right now where you would use it. But I have read about it and kind of seen where people use it a long time ago. I just kind of forget. But that's how we do it. All right. So that's how you do that.
Why is there no slope? Like, why don't they like?
Because remember, you jump up because it doesn't connect because we're not using those points. So if I went to like negative 1.5, I'm not jumping up to here, right? I'm staying here, right? If I go to negative 1.1, I'm staying here because of the definition of a greatest integer, all right? That's why you don't connect them, all right? Because if I connected them, then I'm including negative 1.5 would be at negative 1.5, but that's not what we're doing. Okay, the greatest integer means we're only including integers. And look, everything's an integer here. Well, on the y's, I should say. Okay, on the y's, the answer to this is always going to be an integer. All right, so if you look at your y values, there's nothing in between, right? Because everything's got to be at an integer. It's weird, I know it, but you don't see it a whole lot in here, but you'll see it in pre-calc because I've taught it in pre-calc in the first chapter, I think. So this is definitely something you'll see next year. And I don't know if we'll do more with this or not, so we'll see. So here's an example. We've already kind of talked about this, but this is an example. They call it example 4. and they say evaluate, and we've kind of discussed this already, but all right, so there's your greatest integer function. Okay, when, and they give you 4 different situations, A, B, C, and D, and they say x is 2, x is 3 over 2, x is negative 2 over 3, and x is negative 5. Okay? So what are we going to do here? Well, we're doing this. Well, if I could draw a straight line here. Boom. Nope. There goes my y. I don't know why. Why does it do that? Like all of a sudden, is it... Okay, I think we're back to normal. No, we're not. I used to have to shut it down. Okay, it's still not working. See how it's not making a nice circle? Yeah, but then I got to start the recording all over again. I don't want to do that. Okay, for some reason, I don't know why it happens. It works again, but I don't know what I do. There's no button I push or anything. I don't know. I think I'm saving up. I got one in mind that I'm going to get. No. I mean, this was like $75 or something like that for this tablet. They make them up to like hundreds of dollars, but this one was pretty cheap. And it's actually acting very cheap. All right, so what do? Let's see if I can do this again. There we go. All right, so what is this? If x is 2, what's the greatest integer of 2?
2.
It's 2 because it's the number that's the greatest number that is less than or what? Equal to that number, all right? It'd be a lot easier if we took it from 3/2 and we made it what? 1.5, all right? So what's the largest integer that's less than 1.5? Okay, it's 1. That's right. So if I said, what is the greatest integer function or the greatest integer of 3 over 2, you would just say it's 1. And if it helps doing a number line, where's 1.5? It's between what? 1 and 2. Where do we look? We look just to the left of it, okay, because it's less than. So what integer is just to the left of 1.5? 1 is, right? But a lot of these you can do in your head. Sometimes the negatives are the ones that mess you up a little bit. So let's draw a little. Where's negative 2/3? Well, this would be what? 0, negative 1. Where's negative 2/3? It's in here, isn't it? So what's the greatest integer of negative 2/3? It's negative 1 because it's the integer that's just to the left of that number. So the greatest integer of negative 2/3 is equal to negative 1. Is it making sense to you? Oh, there goes my thing again. Oh, maybe I was just writing it too fast. I don't know. All right, and what about negative 5? That's easy. It's just... Why did I put... Maybe I just messed it up. For some reason on my notes I put 5, but it should be negative 5. Yeah, okay. Stop. Somebody check that. Anybody got their book open? It's negative 5, okay. I think just in my... Let me change that in my notes. Because I know it's negative 5. I just forgot to put the negative. All right. That way next year I won't make the same mistake. All right, let's do some more. All right, that's enough of the greatest integer. Let's talk about absolute value now. Have we graphed an absolute value in here yet? Can't remember if it was this class or my other. It was last class we did?
Yeah, it was last class. Do they have restrictions in them and stuff?
This one does not have a restriction. Oh, on the other ones, listen, guys, I have not stopped. I don't know why you think there was a break here. So we're going to do absolute value. I think when we did absolute value before, all we were looking at was for the domain and range. I don't think they actually asked you to graph it. I think they just put a picture of it. Yeah, and then you just had to determine, and I kind of went through and I showed you what the graph was. So here is officially, all right, the absolute value lesson. All right, so absolute value. And we're going to do some things with the absolute value graph. We're not just going to graph the absolute value and that's it and quit there. We're going to do some more stuff with it. And let's go back to this graph. I just want to copy and paste this so that I'm ready to go. There we go. All right, here we go. Shh. Look, I breathe for half a second and you guys start talking again. All right? Just because I go to something else, I don't understand that. That looks like valve, but it's not. It's a U. V-A-L-U-E. Okay, absolute value. All right, so here's what it looks like. We're going to go f of x equals, you know what absolute value looks like. There's just a couple bars right here. All right. And we talked about this yesterday, so I'm not going to spend a whole lot of time on this. Let's put a -3, -2, -1, 0, 1, 2. And what's the absolute value of -3? It's 3. And then what? 2, 1, 0, 1, 2. We could put a 3 in there if you wanted. There you go. It's not a parabola. It's not a parabola. It's the V. It's a V. All right, so watch. -3, 3. 1, 2, 3. 1, 2, 3. Right there. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. 3, 3. We could keep going if we wanted to. But what's it eventually going to look like? It's eventually going to look like this. And it's going to look like this.
Do you have to keep the line going?
It's a line. So tell me.
Yeah.
Yeah, lines keep on going, right? So, and there's no restrictions to the domain on this, okay? It doesn't say anywhere where there's any restriction or anything. So yeah, it would absolutely keep on going and going. If there was a restriction to the domain, it would eventually stop somewhere, okay? But there you go. So that's kind of easy, isn't it? To graph that. You see it from this table, right? Why it looks like that. What we're going to do now is we are going to do a thing they call I think they call it translation and something else. I always forget the words they use. But we're going to shift it. We're going to shift it up and down. We're going to shift it left and right. So this is really important. This is important not just for absolute value, but it's important for really any graphs that we do. All right. Mia brought up parabolas. Eventually, we're going to do parabolas. Not in this chapter, but eventually we will. And you're going to get formulas or equations that look a little bit difficult. But if you know what this plus means or what this minus means and where it's located, you know whether to shift it up or down or left or right, okay? You'll know whether to take that V and make it more at an angle or flatten it out a little bit more, okay? I don't think we're going to do that in this chapter, but in another chapter I think we will. But this one, what we're going to do is we're going to learn how to move it up and down and left and right. Everybody with me? So let's go different color on this. Okay? If you have a different color pencil, feel free to use it. All right. Now, we've been using f of x, but do you remember at the very beginning talking about functions that we don't have to use the letter f? We usually do because f and function, right, they're the same letter. But you can use any letter. So they decided just to mix it up a little bit since they're different functions, right? This is your f function, and we're going to do a g function. Because I'm not going to write, if I want two different graphs, I'm not going to call one f of x and call the other one f of x. Because that would mean it's the same function. Agreed? So that's why they changed the letters of this. We're going to compare. I'm going to keep this red one here because that's our baseline, right? That's our, quote, normal absolute value graph, if you want to call it that. But watch what this does. Starts with this, but then it does +3. What in the world does that +3 do to that graph? Well, let's see. Let's do the table just because you're used to doing tables, and sometimes it's very, very helpful doing those tables. Even when you do equations that are really complicated, sometimes the best thing to do is go right to the table and start plugging numbers in and see where they line up, okay? So I'm not going to go to -3. Let's just go -2, -1, 0, 1, 2. All right? Let's put that in there. So what does this say? The absolute value of -2 is what? 2 plus 3 is what? 5. Put in a -1. 1 plus 3 is 4. Put a 0 in for this. 0 plus 3 is 3. Put a 1 in for this. 1 plus 3 is what? Look, now we're going back the other way, aren't we? Do you see that? Put a 2 in for this. Absolute value 2 is 2 plus 3 is 5. So let's plot this. -2, 5. 1, 2. 1, 2, 3, 4, 5. -1, 4 would be right there. 0, 3 would be right there. And look at the other side. The other side is going to be a mirror image of that, isn't it? Everybody see that? So there's your 1 or your 2, 5 right there. There's your 1, 4 right there. So check this out. This looks like this. Okay? Still's got that v to it, doesn't it? But now it starts at a different place. Instead of starting at 0, 0, where does it start? At 0, 3. So what do you think that plus 3 did to the blue graph compared to the red graph? It shifted it where? It shifted it up. That's it. Okay? It shifted it up. So when this is just the absolute value of x, and if you have a plus something, what does that do to your original thing? It moves it up. All right? So this moves it up. So I'm not going to do this one, but let's just think about it. What if it said minus 3? Then it would move down. So how would you graph it? If it said g of x equals absolute value of x minus 3, what would you do? You'd come down to negative 3, 1, 2, 3. Now, we didn't change the slope of it, did we? So if you started here, what are you going to do? Up 1 over 1, right? Up 2 over 2. You with me? Up 3 over 3. Yeah? And the other side is going to be a mirror image of this. And then you'd graph it like this. So do you have to do this thing every single time? You shouldn't have to, because you know generally what an absolute value looks like. What does this do to it? It just shifts it up. Okay? It just moves it up. Make sense? And if it was minus, it would move it what? Move it down. Okay? Everybody got that? Now, here's another one. It's a little different. I'm just going to erase this because I just want my graph to be right there. Actually, let's do this. Let me get rid of those dots. Okay, now I'll erase it. All right, let's do another one. Different color. Let's go yellow. All right, here's another one. Let's go h of x this time. Again, because they're different functions. The red one's f of x, the blue one's g of x, the yellow one's going to be h of x because they're different equations, different functions. All right, look at this. Just intuitively, what do you think that's going to do to that red graph? It's going to move it. Okay, I got one saying to the left, one saying to the right.
To the right.
Which one? You saying that just because it's Mia, or?
That's definitely not why.
That's a good question. That's a good question. Okay, let's do this. I'm glad you brought that up. I really am, because I was going to say the same thing. It looks like, doesn't mean it is. It looks like, well, it's not absolute value. Well, it is absolute value. Anyway, let's just talk about it. It looks like this would move it to the left 2 places, doesn't it? Because minus, right? And it kind of makes sense. But when you start putting the numbers in, let's see what happens. Again, we'll just go negative 2, negative 1, 0, 1, 2. So if I put a negative 2 in for this, what's that? Negative 2 minus 2 is negative 4. Absolute value is what? 4. Put a negative 1. Negative 1 minus 2 is negative 3. Absolute value is 3. 0. Absolute value negative 2 is 2. Put a 1 in there. 1 minus 2 is negative 1. What's the absolute value of negative 1? It's 1. Put a 2 in there. 2 minus 2 is 0. Actually, we need some more points, don't we? Let's put a 3 and a 4 in here. Let's put a 3 in this. 3 minus 2 is 1. Absolute value is 1. Put a 4 in there. 4 minus 2 is 2. Absolute value is 2. And you see, it just keeps on going, right? Incrementally. So let's just start with a 0. 0, 2 would go right there. 1, 1 would go right here. 2, 0. 3, 1. It's starting to go back up again. And then what? 4, 2. You getting the idea? So what did it do? Shifted it where? To the right. That's kind of counterintuitive, I think. Okay, maybe you don't, but... And Mia, you probably did this before, right? Yeah, so she knew. All right, so there's that. So look at this. This minus 2 actually moved it in which direction? It moved it to the right 2 places, didn't it? It kind of looks like it should move it to the left 2 places, but it doesn't. So you just have to know when it's inside the function. Everybody listen. When you're adding or subtracting inside the function, that moves it left and right, but it moves it the opposite way than you might think it would move it, okay? You'd think it would go to the left too, but it doesn't. This moves it to the what? to the right 2 when it's inside the absolute value. Remember the g function one we did? What was that? Is that plus 3 inside of the function? It's not. It's not inside the absolute value, is it? All right. When it's outside the absolute value, then we move it up and down. And you move it the direction you think you're going to move it, right? It says plus, yeah, move it up. Okay, if it said minus, move it down. But when it's inside the absolute value, then we're going to move it left and right, and you move it the opposite way than what that sign tells you to move it. All right? So it looks like that means move it to the left, but it doesn't. It actually means move it the other way, and we move it to the what? To the right. So what if I said, we'll just use h of x again, even though I'm going to write something different. What if I said x plus 2? What does that mean you're going to do? You're going to move it to the left 2 places. So you start at the origin, right? Move it to the left. So if I was going to graph this without the table at all, how would I graph this? I would say, okay, I know it's going to look like a V because it's absolute value. And it's plus 2. That means it moves to the left 2 places. And where do I write my lines? It's just basically a slope of 1, isn't it? Right? Up 1, up 2, up 3, right? Just like this, and like this. So once you get the swing of this thing, it's very, very easy to graph, and you kind of get the idea of what it should be. Agreed with that? All right, so that would go up like that, that would go up like that. Are we done yet? Nope. All right, here's what they do. Next thing, this is the last thing they do. Let's grab this graph again. This time they're going to give you a graph, and they're going to ask for the function, okay? So they're going to give you the graph. You got to look at it, and you got to figure out what's going on. Now, you could do a combination of these things, couldn't you? Let's just make one up. Let's just say f of x again. All right, watch. Absolute value of x minus 3 plus 2. Look at that. And that's what we're going to do here in a second. What does this do to our v? It moves it to the right 3. Yep, to the right 3 and up 2. Everybody see that? So if you had something like this, let's go different color. I'm not going to run out of time, so I got to do this quick. So normally we'd start here, and we go to the right 3, 1, 2, 3, and we go up 2, 1, 2. So this is our starting spot with this one right here. Everybody see that? And then how do we draw the rest of it? Go up 1 over 1, up 1 over 1 again, and then you do this, this, and this. Connect them, and you've got it. Okay? No, I'm just doing it just to save time. It's a little sloppy. Well, it's not really that sloppy. It's actually pretty good. Go right there. Yeah.
What's the other yellow dot for?
Because remember I said this one right here, if I shifted it, if I went x plus 2, I just didn't put the lines in there. It's already messy enough. All right, enough of that. Here's what we're going to do. I'm going to put this on here, and let's see. What color? Let's go orange. We haven't gone orange in a long time. So this is at -1, -2. -1, -2. All right? And everybody watch. Put a dot here, dot here, dot here, dot here. Then this goes up like this. And then this one goes up like this. There's your graph. And you have to tell me what that function is. What's the equation of that graph? We'll just call it f of x. All right. So where do we start? What do we do? Normally we'd start there, right? What do we do? We went to the left 1, and then we went what? Down 2. So that point right there is what? -1, -2. Okay? So how would I write this? Let's do it right here instead. F of x equals. Now, it's absolute value. How do you know it's absolute value? Just by looking at it. Because it's not a triangle. It's a V. It's a V. All right? So, and it goes up 1 over 1, up 1 over 1. So you don't have to worry about that. So I'm going to have an absolute value, but what am I going to put in the absolute value? X what? I moved it. I went to the left 1 place. So what does that mean as far as this is concerned? If I go to the left 1 place, what do I put inside the absolute value? x plus 1. That's good. All right, I can close that off because that's the only thing that happens inside of there. Now I go down 2 places, so what does that mean I do? Minus 2 on the outside of that absolute value. So there you go. That's all there is to it. So if you were given a graph like this, you should be able to come up with the equation of that line. And that's the equation of the line. Okay. Yeah, it was pretty simple. Now, we're going to be doing that same kind of thing with other shapes, okay? Like a parabola, we'll talk about that at some point, and a bunch of other crazy looking things, all right? But we're not going to do that right now. That's down the road, okay? Everybody got this? It's not too hard, is it? Yeah, it's a V, so you know it's absolute value, right? And you went to the left 1, down 2. So this plus 1 means we go to the left 1, right? That means we go to the left 1 place. This minus 2 right here means we do what? Go down 2. If you understand this, it's going to help you out a lot when we start graphing other things. And there's a lot of graphing in this course, all right? Not as much as there is in pre-calc. In pre-calc, we'll probably do a whole lot more. But in here, we do a good share of graphing, and you got to make sure you know what all these things mean and what they do to it, all right? Wouldn't you agree it's a lot better understanding what's going on than doing this? Wouldn't you hate to do this for every single graph that you ever do? Yeah, right? Because, I mean, that's a lot of work. You don't know how far over you got to go, you know, and all that kind of thing. And it should be a pain, right? But it's good to know what's going on here because you can graph it just like that. No big deal. All right?
Wait, what is like pre-algebra?
Pre-algebra or pre-calculus?
Yeah,
Whoops.
like, what is that? Like, what,
It's just a continuation of this, basically, is all it is. All right, so let's see. I think I've told you for a couple days that it'd be a good idea to get started on some of these. Has anybody actually done that? Okay, good. So some of you you won't have to do them all, but some of you will. So it's 7 to 28 on section 2.5. It's pages 85 and 86. All right, and that's section 2.5. All right, so that's your homework. For some of you, you only have a handful to do. For others, you got them all to do. All right, so there you go. That's it. Tomorrow, or not tomorrow, but Monday, we'll... no, I still got to do 2.6, yeah. I got to do 2.6 before we do the quiz. All right, so the next quiz is going to be 2.5 and 2.6. All right, so we'll probably take the quiz Wednesday, probably. Yeah. Nah, there's no way we can have a test. All right, that's enough. Have a good weekend.